Today's lesson has to do with the rational root theorem. I want you to draw your attention to the middle of the screen here, where I'm talking about the rational root theorem. And what I want you to understand, because I'm going to summarize this, we are going to be able to list the possible solutions of polynomials. And we're going to do it by figuring out the ratio, or determine the ratio of the constant factors, which is this right here, the constant factors of 10. In this case, it's 1, 2, 5, and 10. So we would have that in our numerator. It's the ratio of the constant factors over the leading coefficient factors. And why is that important? We have a pool of numbers that we can figure out what could be the solution to the polynomial. So what we're going to do is I'm going to go ahead and figure out the possible solutions for a polynomial, and then we are going to use the equation itself to see if the remainder is equal to 0, because if the remainder is equal to 0, then we know it's a 0 of the polynomial. Okay. It says finding a rational root. What are the rational roots for 2x cubed minus x squared plus 2x plus 5? Remember, we're going to find the possible roots, or the possible solutions. So we have 5. The factors of 5 are 5, plus or minus 5, plus or minus 1. Those are the possible factors of 5. 2, the possible factors of 2 are plus or minus 2, plus or minus 1. So we know that the answer could either be, and we're gonna go ahead and I'm gonna go ahead and write the ratio here. So we have plus or minus 5, plus or minus 1. We have plus or minus 2, plus or minus 1. So if you wanted to list the possible solutions, it would be 5 over 2, plus or minus 5 over 1, which is 5. And then we go to 1, so we have 1 plus or minus 1 divided by 2, or we have 1 plus or minus 1. So these are your possible answers, and I'm going to write here on the side possible solutions. So now what we're going to do is we're going to use synthetic division, and we're going to check if it's a 0. Because if it's a 0, then I know that it is a solution to the polynomial. So I'm going to try 1. So I'm going to write 1. So I have 2, negative 1, 2, and 5. Remember, I'm looking for a remainder of 0. If I find a remainder of 0, then I know that that is a root, or that is a solution. So you have 2, 1 times 2 is 2, negative 1 plus 2 is 1, 1 times 1 is 1, 2 plus 1 is 3. That's not going to be it, because the remainder is 8. So we know that P of 1 equals 8. That's not going to work. So let's try negative 1. And what I'm going to do is I'm going to go ahead and move it just a little bit to the left. Okay. So let's try negative 1. Just remember, negative 1 is also a possible answer. So we have 2, negative 1, 2, 5. Bring down the 2. Negative 1 times 2 is negative 2. Negative 1 plus negative 1 is negative 3. Negative 1 plus negative 3 is 3. 2 plus 3 is 5. Negative 1 times 5 is negative 5. 5 minus 5 is 0. So that is an answer because P of negative 1 equals 0. So my first answer is x equals negative 1. So what do we have as a quadratic? We have 2x squared minus 3x plus 5 equals 0. Now at this point, if you want to use a quadratic formula, you can. Or you can continue testing these possible solutions. I'm going to use a quadratic formula. So you have x equals negative b plus or minus square root b squared minus 4 times ac divided by 2 times a. So I know that a is 2. I know that b is negative 3. So I'm going to write a is 2, b is negative 3, c is 5. So I know that b is negative 3, so it's going to be 3 plus or minus square root. And I know that b squared is negative 3 times negative 3, which is 9, minus 4 times a, which is 8, times c, which is 40. So I have 3 plus or minus 9, minus 4 times a, which is 2, that's 8, times c, which is 40. So I have 9 minus 40 over 2 times 2, which is 4. 3 plus or minus square root 9 minus 40 is negative 31 over 4. So what does this tell us? It's going to be two imaginary answers. So we have 3 plus or minus square root of 31i over 4. I'm going to first try to figure out the possible roots. So what I'm going to do is I'm going to find the factors of the constant, which is 6, which it could be 6 because 6 is a factor of 6. I know that 6 has a factor of 2. I know that 6 has a factor of 3, and 6 has a factor of 1. So I'm listing the factors of the constants. 1, there's only plus or minus 1. So now what I'm going to do is I'm going to list the possible roots, or I say solution. And it's going to be the possible factors of the constant over the leading coefficient. So it's actually 6. I'll write it out. It's going to be plus or minus 6, plus or minus 2, plus or minus 3, plus or minus 1. It's all divided by 1. So what are my possible factors? 6, 2, 3, 1. So what I'm going to do is I'm going to go ahead and you're probably saying, well, how do you do this? I mean, how do we figure out which one it could be? So what you do is you first check, or you kind of, I don't want to say guess, but you do try your best to, it is guess and check. So let's go ahead and try 2. Let's try 2. So I have 2. I have 1, negative 5, 4, 6. And so I'm just guessing it's 2. 1, 2 times 1 is 2. Negative 5 plus 2 is negative 3. 2 times negative 3 is negative 6. 4 plus negative 6 is negative 2. 2 times negative 2 is negative 4. And that gives you a 2. So that's not going to be it. But let's check again. We bring down the 1. 2 times 1 is 2. Negative 5 plus 2 is negative 3. Negative 3 times 2 is negative 6. You have negative 4 when you add. 2 times negative 2 is negative 4. So 6 plus negative 4 is 2. So 2 is not an answer. Let's try 3. Let's try 3. 1, negative 5, 4, 6. Bring down the 1. 3 times 1 is 3. Negative 5 plus 3 is negative 2. 3 times negative 2 is negative 6. 4 plus negative 6 is negative 2. 3 times negative 2 is negative 6. 6 minus 6 is 0. So the remainder is 0. So that is an answer. So I'm going to write x equals 3 as an answer. So now we have x squared minus 2x minus 2 equals 0. And if you want to use the quadratic formula, or you can use factoring. No, we probably want to use a quadratic formula. So let me go ahead and write down the quadratic formula. So we have x equals negative b plus or minus square root b squared minus 4 times ac over 2a. So I'm going to substitute. So b is negative 2, so it's 2 plus or minus square root. Negative 2 to the second power is 4. So I have 4 times 1. I have 4 times 1 is 4. Times c is negative 2, so it's negative 6. Negative 8 plus a negative gives you positive 8. Divided by 2 times 1 is 2. So x equals 2 plus or minus square root of 12 divided by 2. And this right here simplifies. Square root of 12 is the same thing as saying square root of 4 times the square root of 3, so it's 2. So it's 2 plus or minus 2 square root of 3 over 2. So my other answer, because I'm running out of room, my other answer is, you have 2 divided by 2 is 1, plus square root of 3, and then the last answer is x equal 1 minus square root of 3. By the way, this is a theorem, and these are called conjugates. If one is 1 plus square root of 3, you have to have the other one. 1 minus square root of 3. They come in pairs. So there is a 3 solutions, okay? So we're going to come up with the possible roots. We have 4 plus or minus 4 plus or minus 2 plus or minus 1. And then the leading coefficient plus or minus 1. So what are our possible roots? Plus or minus 4, plus or minus 2, plus or minus 1. We're going to use synthetic division to check. So let's go ahead and use negative 1. So we have 1, 3, negative 3, negative 12, negative 4. So we have 1, 3, negative 12, negative 4. So it's 1. Negative 1 times 1 is negative 1. 3 plus negative 1 is 2. Negative 1 times 2 is negative 2. Negative 3 plus negative 2 is negative 5. Negative 1 times negative 5 is 5. Negative 12 plus 5 is negative 7. And that's not going to work because that's 7 and it's a remainder of 3. So that doesn't work. Okay, let's try 2. Or let's try 2. So we have 1, 3, negative 12, and negative 4. Bring down the 1. 2 times 1 is 2. 3 plus 2 is 5. 2 times 5 is 10. So bring down the 1. 2 times 1 is 2. 3 plus 2 is 5. 2 times 5 is 10. Negative 3 plus 10 is 7. 2 times 7 is 14. Negative 12 plus 14 is 2. 2 times 2 is 4. Negative 4 plus 4 is 0. That's a remainder of 0. That's what we want. So we have x equals 2. That's our first answer. Let's go ahead and try 4. Let's try 4. 4 is an answer. So we have 4. I have 1, 3, negative 3, negative 12, negative 4. So we have 1. 4 times 1 is 4. 3 plus 4 is 7. 4 times 7 is 28. That's going south. 24. Yeah, that's not going to be it. I like to focus our attention on this polynomial. I'm going to rewrite it. We have x to the third plus 5x plus 7, x squared plus 7x plus 2. Here I have a 2 and I have a 1. So the only thing I have to check is either 2 or negative 2. So let me go ahead and try negative 2. So it's 1, 5, 7, 2. 1, negative 2 times 1 is negative 2. 5 plus negative 2 is negative 3. 5 plus negative 2 is 3. Negative 2 times 3 is negative 6. 7 plus negative 6 is 1. Negative 2 times 1 is negative 2. 2 minus 2 is 0. So I found the other answer. X equals negative 2. So now let's focus our attention on 1, 3, 1. So I have x squared plus 3x plus 1. And I'm going to tell you, I think that's going to give you an imaginary solution. So I'm going to have to move this over for a little bit right now. So here is my negative b plus or minus square root b squared minus 4 times ac over 2a. So I know that b is 3, so I'm going to say negative 3 plus or minus square root. So b squared is 3 squared, which is 9, minus 4 times a, which is 1, times c, which is 1. So it's 4 over 2. So x equals negative 3 plus or minus square root of 5, because 9 minus 4 is 5 over 2. Okay. So let me go ahead and give you the other answers. So it's 2, negative 2, and then we have x equals negative 3 plus or minus square root of 5 over 2. And you notice that it's to the 4th power, so we have 4 answers.